So this is my lab one presentation about constant velocity. So we will go over like an introduction, the formulas I use, the experiment, coding, results, and conclusion. So the purpose of this lab was to connect experimental observations with a computational physics model, showing how a constant velocity situation can be described by both real data and conceptual physics. So here are some physics principle I use. So Newton's first law, the law of inertia, object in motion stays in motion unless acted upon a net force. Newton's second law, momentum, a heavier object requires more force to move. So F equals ma. Constant velocity, that force is zero, and an object moves at constant velocity. So here are some formulas I use. So this is the velocity update formula. This is the position update formula. It's the average velocity. This Newton's second law. So these all come into play for this lab. So here are the results. So as you can see, I got a relatively straight line, which means the marker was moving at constant velocity. And this is my ruler with the scale. So for our experiment, the object was a marker, and in the environments or things like wind resistance, frictions, and etc. And then experiment position, I use tracker, and for predicted positions, I use glow script, and then results are shown on a graphic Google Sheets. So procedure. So first I recorded the object moving at constant velocity. I uploaded the video to tracker to get a recorded value, and then I use glow script to get my predicted value, and I put it into Google Sheets to get a comparison of the two. So initial conditions. So my total time was 1. And then this is my initial position. So it's going to be 4.856 times 10 to the negative 3. And then this is how I got my initial velocity. So I took my final point and then subtracted by the initial point. And then also here, force and friction is negligible. So here are some initial conditions and where they are in glow script. So this is my mass of the object. This is my initial conditions from tracker. And then this is the frames per second. This is my total time. This is my net force. And this is the position update formula. And so as you can see here, my predicted line is very similar to my experimental line, which shows that the marker was indeed moving at constant velocity. So here are some possible sources of error. So my system here, the marker, and sources of error could be like human error, or like friction could slow down the object and make the graph curve. As you can see, there was some areas that was curved and not straight. And an air resistance also do the same thing as friction. So what if the axis were flipped? So of course the signs would switch, and then the slope would also be negative. And then can we tell how many forces are added together? So we only know that the net force is 0. We don't know all the forces, and we only know that the marker is moving at constant velocity. So conclusion is our actual and expected results were similar, so we can assume that there was constant velocity with no net force. Thank you.